Hello everybody, this is Manveen and today we're going to talk about JVM or Java Virtual Machine. This is the third video in my Java playlist and excuse me if I yawn during the video because I'm recording this at 2 a.m. in the morning. So before talking about JVM, we need to know the difference between a compiler and an interpreter. So a compiler, as you know, is a software that compiles or executes and scans your code all at once. And an interpreter scans your codes or interprets your code line by line. So the main difference is that a compiler will show all the errors all at once, but an interpreter will, since it interprets line by line, it will not move to the next line unless you have removed all errors from the line that it has interpreted. So suppose there are 5 lines in your code, it will first fix the line in the first code, it will show you the error, and then it will go to the next line in the code. So that's how an interpreter works, and that's how a compiler works. So as I had explained in my previous video, Java is both compiled and interpreted. So it has features of both. So I have made this diagram to explain how the JVM in Java works. And JVM is one of the most important concepts in Java to understand how it works. So firstly, we have the source code. The source code is the program that you write and you give to your IDE, and the source code then gets converted to the bytecode using the compiler, Java compiler. Bytecode is basically your binary digits, zeros and ones, code written in zeros and ones that your computer can understand. This bytecode is then converted to the machine code by the Java virtual machine. Java virtual machine is an interpreter. So, as I had mentioned, you're first converting your source code to bytecode using the compiler, and then you are converting your bytecode to machine code using an interpreter, JVM. So, you're using both compiler and interpreter. So, now you know why Java is called a compiled and an interpreted language. It is not one of those, it is both of those things. So, what is JIT? JIT is just in time compiler. So, it is a part of JVM and it makes your Java virtual machine more efficient. So, we over here we had learned that JVM converts your byte code into machine code after your source code has completely been converted into your machine code, and after your byte code has completely been converted into your machine code. But what just-in-time compiler does is that it converts a little bit of the bytecode into machine code during execution. What JVM does is that it converts bytecode into machine code after execution of the bytecode. But just-in-time compiler does the same during the runtime of the code. So, for example, as I have mentioned over there, let's take an example of a book. So what JVM does is that uh, it will scan the entire book and then it will execute the bytecode and then it will convert it into the machine code. But what just-in-time compiler does is that it will take the first page of the book, it will scan it during execution, and then it will after the execution it will easily convert bytecode into machine code. So since just-in-time compiler already knows what the first page entails, it becomes easier for JIT to convert the bytecode into machine code, unlike JVM, where nothing has been scanned during its execution. So it does the work after the execution, while just-in-time compiler does everything during the runtime. So this is why Java is very portable, and this compiler makes Java more efficient in nature. So now let's come to the concept of garbage collection. This concept is what makes Java different from other languages, because in my first video I had also mentioned that suppose when you write a program and you declare multiple objects, you write a very lengthy program and you declare multiple objects, and this is done using the new keyword, and using the new keyword you are dynamically allocating memory uh, to create more objects. You're creating more space so that more objects can get inserted into your memory. So automatic allocation of memory is taking place. The opposite in Java happens as well. Automatic deallocation of memory also takes place. This is known as garbage collection. So what happens is that when you declare multiple objects, and suppose you write a very lengthy program and you're not using the objects that you used in the beginning of the program, so that is already consuming a lot of memory. So if you're not using those objects later on for a very long time, those objects are removed from memory so that the overflow of memory does not take place. So that is known as garbage collection. This is done automatically, and this is called automatic memory deallocation. And automatic memory allocation also takes place in Java. So to summarize what I have said, we spoke about the difference between a compiler and an interpreter. Compiler does everything together. Interpreter interprets it line by line. Then we spoke about JVM and how Java is both a combination of a compiled and an interpreted language because it has the Java compiler and the JVM, that is an interpreter. And we spoke about just-in-time compiler, which makes the JVM working of JVM more efficient because it happens during runtime, while JVM happens after its runtime. I gave the example of a book as well. And after that, I spoke about garbage collection, that is the automatic memory deallocation of objects. I spoke about how objects are allocated. So, this is all for today's video. And please like, share, and subscribe. You can comment as well if you want me to make videos on topics that you want. So, thanks for watching.